Adding and subtracting dissimilar rational algebraic expressions. How do we add and subtract dissimilar rational algebraic expressions? Let's have an example. We will have here 7 all over 12x raised to the power of 4, y raised to 3, and c raised to 2 plus 14 all over 8x squared y raised to the power of 5. To solve this dissimilar rational algebraic expression, first we need to find the LCD. We need to find the LCD of the denominators. So LCD stands for lowest common denominators. It's also the lowest common multiples of the terms here in the denominators. So let us now find for the LCD of 12 and 8. So the LCM here of 12 and 8, for 12, we have here the multiples of 12, 24, 36, 48, and for 8 we have 8, 16, 24, and so on. Now we will stop at 24 because we have here the common multiple now. Okay, so the lowest common multiple of 12 and 8 is 24. And then let us find the LCM of x raised to the 4th and x raised to 2. We will have here x raised to 4 and x raised to 2. Their lowest common multiple will be the one with the highest exponent rather. So their LCM here is x raised to 4. How about for y raised to 3 and y raised to 5? Okay, we have here y raised to 3 and y raised to 5. The lowest common multiple again is the one with the highest exponent, and this will be y raised to 5. And then we have here c raised to 2 without any pair, so automatically c raised to 2 will be the lowest common multiple. Okay, now that we have here the different lowest common multiples, we can now use them for our lowest common denominator. And this will now be our fraction. So our LCD now will be, we start with 24, and then we have x raised to the power of 4 and y raised to the power of 5, and then c raised to 2. This is our LCD. And just like in the operation of fraction, we are going to divide this LCD with the denominator. Okay. And then multiply the result with the numerator. So we will now multiply the numerator, that will be 7, and multiply this by the quotient. So 24 divided by 12, that is 2. X raised to the 4th divided by x raised to the 4th, that is equal to 1. Y raised to 5 divided by y raised to 3, that is y raised to the power of 2. We just subtract the exponents. C raised to the power of 2 divided by c raised to the power of 2, that is equal to 1. And then we will have here plus, okay, we have 14. This will be multiplied by the quotient. Our quotient will be 24 divided by 8. That will be equal to 3. X raised to the 4th divided by x raised to the 2. That will be x raised to the power of 2. Y raised to 5 divided by y raised to 5. That is equal to 1. And then we have c raised to the power of 2. And then we are going to perform 7 multiplied by 2. That is 14. Multiplied by y squared, so 14y squared, plus we have here 14 multiplied by 3, that is equal to 42, and we have x squared c squared. With the denominator or the LCD, which is 24, x raised to the power of 4, y raised to the power of 5, multiplied by c squared. Okay, now we will then factor out those that can be factored out. As you can see here, we have 14 and 42. 14 is common between the two, so we can put 14 outside. This will be 14 here, and then we will have here, so 14y squared divided by 14, this will be y squared, plus 42 divided by 14, that will give us positive 3, and then just copy x squared c squared all over our LCD, which is 24 x raised to the power of 4, y raised to the power of 5, and c raised to the power of 2. But then we have here 14 and 24. 14 and 24, 2 is common between the two, so divide the numerator and the denominator by 2. 14 divided by 2, that is equal to 7, and 24 divided by 2, that is equal to 12. Okay, what will be left now will be 7 multiplied by y squared plus 3x squared c squared all over 12 x raised to the power of 4, y raised to the power of 5, and c squared. Therefore, 7 multiplied by the quantity y squared plus 3x squared c squared all over 12 x raised to the power of 4, y raised to the power of 5, and c raised to the power of 2. This is our final answer. Here is another example. We have the quantity of 2x plus 1 all over x squared minus 10x plus 25. The quantity of x minus 4 all over the quantity of x minus 5, multiply this by the quantity of x plus 5. To solve this rational algebraic expression, first we need to factor out x squared minus 10x plus 25. So factoring this will now give us, so this is still 2x plus 1, but for our denominator, the factors of x squared, this will be x multiplied by x, and then the factors of positive 25, this is a perfect square, so the factors will be 5 multiplied by 5. And since this is negative and we need to have the sum of negative 10, all we need to do is put here negative multiplied by negative, since negative multiplied by negative is positive. And then we have here minus the quantity of x minus 4 all over the quantity of x minus 5 multiplied by x plus 5. Now, to subtract this, just like in subtracting fractions, we need to find for the least common denominators. Now, the least common denominator here, or the LCD, will be, for example, this one, x minus 5 times x minus 5. This is equal to, okay, so let's rewrite this first. So 2x plus 1, we can rewrite this as x minus 5 raised to the power of 2 minus x minus 4 all over x minus 5 multiplied by x plus 5. Now, x minus 5 and x minus 5, since they are of the same quantity, so the LCD now of x minus 5 squared, okay, the LCD of x minus 5 squared and x minus 5, their LCD here will be the one with the highest exponent. So the LCD now will be the quantity of x minus 5 raised to the power of 2, since it has a larger exponent as compared to this one, which only has 1. And the LCD of the quantity of x plus 5, it would still be the quantity of x plus 5. Okay, so we have here the LCD will be the quantity of x minus 5 raised to the power of 2, and the other one will be the quantity of x plus 5. And just like in fraction, we are going to divide the LCD by the denominator and multiply by the numerator. Our numerator here will be the quantity of 2x plus 1. And then the quotient now, this one divided by this one, it will be equal to the quantity of x plus 5 minus our numerator here, the quantity of x minus 4, and multiply this by x minus 5 squared multiplied by x plus 5 divided by the quantity of x minus 5 multiplied by x plus 5. What will be left will be x minus 5. Okay. And we will then multiply. So 2x, okay, we will have here the quantity of 2x plus 1 multiplied by x plus 5, and using the FOIL method. So 2x multiplied by x, this will give us 2x squared. 2x multiplied by positive 5, this will give us positive 10x. And 1 multiplied by x, this will be positive x. And positive 1 multiplied by positive 5, this will be plus 5. And combining like terms, we will have 2x squared plus 10x plus x, that is equal to 11x plus 5. So we have here 2x squared plus 11x plus 5. And then we are going to multiply this also. So we have here x minus 4 multiplied by x minus 5. Again, using the FOIL method, we have x multiplied by x, this will be x squared. X multiplied by negative 5, that is negative 5x. And negative 4 multiplied by x, negative 4x. And negative 4 multiplied by negative 5, positive 20. And this will now be x squared, negative 5 minus 4x, this will give us negative 9x plus 20. So we have here negative, and since this is a whole quantity, let's enclose that by a parenthesis because of this negative sign. So we have here x squared minus 9x plus 20 all over, we have here the quantity of x minus 5 raised to the power of 2 multiplied by x plus 5. And then we are going to multiply the terms here by the negative sign. So 2x squared plus 11x plus 5. Negative multiplied by positive, this will be negative x squared. Negative multiplied by negative, this will be positive 9x. And negative multiplied by positive, that is negative 20. All over the quantity of x minus 5 raised to the power of 2 multiplied by x plus 5. Okay, so we will combine here like terms. 2x squared minus x squared, this will give us x squared. 11x plus 9x, this will give us positive 20x. And then positive 5 minus 20, this will give us negative 15. All over our LCD, which is the quantity of x minus 5 squared multiplied by x plus 5. Okay, and then let us see if we can still factor this out. Okay, no, there is. Okay, so if we cannot factor the numerator, we have to multiply the denominator. Okay, so how do we multiply the denominator? Let us first perform this. X minus 5 raised to the power of 2, that is equivalent to x minus 5. So this will be equal to x squared. Okay, we have here x multiplied by x. And then we have negative 5x. And we again have negative 5x. And negative 5 multiplied by negative 5, that is positive 25. So this will give us x squared, negative 5x minus 5x, negative 10x plus 25. But we still have to multiply this by the quantity x plus 5. So to multiply a trinomial by a binomial, we are going to arrange it like this. X plus 5 with x squared. So x squared multiplied by x, this is x cubed. Negative 10x multiplied by x, negative 10 x squared. And x multiplied by positive 25, that will be positive 25x. Next, we are going to multiply 5. So we have here positive 5 multiplied by x squared, that is 5x squared. So we are going to align this to negative 10x squared. So this will be 5x squared. And positive 5 multiplied by negative 10x, that's negative 50x. Positive 5 multiplied by positive 25, that will be positive 125. And then we are going to no term here, we will just bring down x3. Negative 10 plus positive 5, this will give us negative 5x squared. Positive 25 plus negative 50, this will give us negative 25x. And just bring down positive 125. So this one now, our final answer here, this will be x squared plus 20x minus 15. All over, for our denominator, this will now be x raised to the power of 3 minus 5x squared minus 25x plus 125. This is now our final answer.